Hassler here. I'm just going to do a video on the 3.3 lesson that we did in our groups today. This is actually in your notes packet, so you can follow along and fill this out with me in your notes packet. We did this at our tables, and we did some more with these Mathagon balance scales. And so it says click on each link below and play with the scales. What do you have to do to maintain balance? Describe your process, write an equation. And so if you click on this first balance scale, this is what you should get. And this is balance scale number 1. And I noticed that I have 3 bells and I have 9 units. So I have these 3 bells, we'll call them 3x plus these 9 orange blocks. And over here I have these 5 bells and I have these 5 orange blocks. And because this is balanced, I can say that these are equal to each other. And so when we talked about solving equations before, we said, well, I want to know the value of each bell. I want to know how much each bell weighs, or in our case, the value of each x. And so one of the things that we did is we started removing things, same things on each side. So there are some things I could do here. I could start by either removing bells on each side, or I could remove these orange blocks on each side. And what I typically like to do is I like to remove the bells on each side. I just like to get rid of them first. It does not matter which one you do first. It's totally up to you which one you do first. But I'll get rid of my bells. So I'm able to get rid of 3 bells on this side. And when I do that, notice I go out of balance. So I have to get rid of the same number of bells on this side. I'm going to get rid of 3 bells on this side. And notice that I go back into balance. So getting rid of those 3 bells is really like saying, all right, I'm going to take away 3 x's on each side. And so when I do that, I have no more bells. So I have just 9 orange blocks. And over here, I only have 2 bells. And I still have 5 orange blocks. So I've gotten rid of the bells on one of the sides. And now this feels like an equation that we've been working on earlier in our unit, right? Where we said, okay, well, now I'm going to take away the same number of orange squares on each side. So I can take away 5 orange squares on this side, which means I have to take away 5 orange squares on this side. And notice I'm back to balancing. So that would be like a -5 and a -5. You can see that I now have, right, 4 of these orange squares, and I have 2 bells. So I'm going to break these up into 2 groups, right? Each bell then would have 2 orange units, and I'm balanced, right? So that's me finishing this out, right? I had 4 orange squares. So if I divide my bells up into 2 groups and my 4 squares into 2 groups, I get that each bell or each x is worth 2. All right, so I'm actually going to come back over here on my paper, and that's what I would fill out here, right? I would say, well, we had 3x plus 9 was equal to 5x plus 5. I like to draw my line down. That's my balance. We said we could also draw like that scale, a reminder to stay balanced. And the first thing that we did is we got rid of the bells on each side. So that left me with 9 equals 2x plus 5. And then we got rid of the same number of orange blocks on each side. So we had 4 equals 2x. And then I divided those bells into 2 groups. And I divided my 4 orange squares into 2 groups. And so each bell weighed 2, or each x was worth 2. And then I can check this just like we've checked our other equations, right? I can go back and say, well, to check this, I would have to do 3 times 2 in place of x plus 9. And does that equal 5 times 2 plus 5? So 3 times 2 is 6, and 6 plus 9 is 15. Over here, I get 5 times 2, which is 10, plus 5 is 15. And so, yeah, those are equal to each other. So let's take a look at what happens in balance scale number 2. So you should get something that looks like this for balance scale number 2. I have this 2x, and then I have minus 7 blocks. And so I'm going to write that as, I'll write it over here. We have 2x, and then we have these pink blocks, negative 7. And that's balanced or equaled with 5 x's and then 2 positive blocks. We talked about this the other day. So if I were you, I would just write this out. You would write it out right here you would write it out right here in this spot. I'm just going to do it on this page here so that we can kind of see it all together. But you're going to fill out your notes there. All right, and so we had talked the last time about I like to remove those bells first, or in this case, I like to remove those x's first. And so I can take 2 x's away on this side, which means I'm not balanced. So I have to take 2 x's away on this side. And now I'm back in balance. And so we see that as, hey, I'm going to take 2 x's away on each side. I'm taking that smaller amount of x's away. I still have negative 7 blocks, right? Those pink blocks. And this is equal to 3 x's now plus 2. Now, we talked the other day about how do I get rid of things that I don't want, right? And so my goal is to isolate x. My goal is to get this x isolated, which means that I want to get rid of, I want to remove anything that is on the side with x. But I can't just pull away these 2 blocks. I'm uneven. And if I pull away 2 blocks here, I'm still uneven because I'm not pulling away the same value. And so we had said, well, to get rid of those 2 blocks, I would have to add 2 to make that, I would have to subtract 2, add 2 negatives to make that 0, which means I have to add 2 negatives here. Adding 2 negatives is really saying I'm going to add a negative 2 and add a negative 2, or that's the same as saying I'm subtracting 2. So now I have negative 9 pink blocks equals 3 x's. And if I divide those x's into 3 groups, I have 1 x in each group. And if I divide my negative 9s up into 3 groups, then I have negative 3 in each group. And so let's just test that, right? I should be able to pull all but 3 out. I should be able to pull these 2 x's out, and I am balanced. So it's that idea of adding these negative blocks to help cancel out the orange blocks. All right, the third equation looks like this. And so again, you're writing in your notes where it says balance scale number 3. And I'm going to be filling this out. Go like this. I'm going to be filling this out here in class or on the screen here with you. So this one looks a little bit different because it looks like I have negative 2 x's and 4 orange blocks. And that's equal to a positive x, but negative 8 pink blocks. Okay. And so what that means is that I have to be able to get rid of x's on one of the sides. It's just like when we get rid of these orange or pink blocks. I like to work with positive x's if I can. And so I'm going to take these positive x's, and if I hover over the pink x, it becomes 0. So to get rid of the negative 2 x's that I have, I can add 2 x's, 2 green x's, which means I have to do that to the other side, and I stay balanced. And so this looks like the following. To get rid of the negative 2 x's, I'm going to add 2 x's. That way I don't have those anymore. I still just have 4 orange blocks, and now I have 3 x blocks. And now I'm back to solving an equation like what we've been working on, right? We said that I want to get rid of these right here, right? Because I want the x's to be by themselves. And so to get rid of those, I would have to add 8 of these. Let's see. I would have to add 8 of these. Does that do it for me? 1, 2, 3, 4, 5, 6, 7, 8. So I'd have to add 8 over here. 1, 2, 3, 4, 5, 6, 7, 8. I don't know that that's going to be quite enough, but you get the idea. And so I would add 8. And so I get 12 equals 3x. And if I divide, I thought that would do it for me. If I divide each of these sides by 3 or put them into 3 groups, we get that x is equal to 4. And so I just want to test that out. I want to see if my scale is balanced. And there it is, x equals 4. All right, so let's take a look at this last one here. Oh my, all right, let's see. This one says that I have 4 x's and a plus 8. And this side says I have 4 x's and a plus 3. And if you notice, I'm out of balance. Is it possible for me to ever be in balance? Well, let's see. If I take an x away here, oh, now it looks like I'm in balance. But what I do to one side, I have to do the other, so I'm out of balance. In fact, if I want to maintain equality, meaning I have to complete the same operation on each side, if I take away my x's, if I do this, if I say, well, I'm going to take away my x's on each side, I'm left with 8 equals 3, which is not true. And we say there's no solution. If I could spell solution. There's no solution. There's no number for x that would ever make this statement true. Or pick your favorite number. My favorite number is 12. So that means if I go to check this, 4 times 12 plus 8, would that equal 4 times 12 plus 3? No, because I have 48 plus 8, and over here I'd have 48 plus 3. Those things will never be the same. It doesn't matter which number I choose. There's no solution that would make this statement true. And so sometimes we run into these cases. All right. So one of the things that I do want to have us write down here is that I like to eliminate that variable term first on each side. I like to keep the variable term positive if I can. When I say eliminate the variable term on both sides first, what I mean is get rid of the variable term. What I do to one side, I have to do to the other. And we want to use these inverse or these opposite operations to maintain balance. Okay. And so we can apply those ideas here to these examples, right? It says given that 7w plus 4 equals 5w plus 12, right? 3 more equations you know to be true. Well, I could add a w to each side. So that would be 8w plus 4 equals 6w plus 12. I could have subtracted 1 on each side. So I would have had 7w plus 3 equals 5w plus 11, right? The idea is that I can create any number of equations as long as they're still equivalent to the original. And they're equivalent to the original by doing opposite operations on each side, right? So again, I could go back here and I could say, well, I could subtract 4 on both sides. That would be 7w equals 5w plus 8, as long as you maintain balance. So now it says to find w. So I'm just going to rewrite this. 7w plus 4 equals 5w plus 12. Just like with the scales, I like to get rid of the variable blocks on each side. I'm going to take 5 away on each side. So I still have 2 w's left on the left side. Plus 4 equals 12. Now I'm going to subtract 4. I get 2w equals 8. If I divide by 2, w equals 4. So down here it says solve each equation. Looks like we have a little bit of everything mixed in here. So again, I like to, you can either draw your scale or draw your vertical bar. I like to get rid of the variable term first, the smallest variable term. So I'm going to subtract 2x on both sides. I get 2x plus 11 equals 5. So now I'm going to take the 11 away on both sides. I get 2x equals negative 6. And if I divide both sides by 2, I get x equals negative 3. And then I can always check it, right? I can go back and say, well, 4 times negative 3 plus 11, and 2 times negative 3 plus 5. If I type those in my calculator, I should get 1 equals 1, and I do. All right, let's take a look at problem 4. It looks like I have some distributive property, so I want to take care of that first. Distribute means to multiply to each term inside. I get 15 minus 6x equals x plus 15. I'm going to add 6x to both sides. If I can make my variable term positive to deal with, I actually think that's easier. I get 15 equals 7x plus 15. Now I can take 15 away on both sides. I get 0 equals 7x. And 0 divided by 7 is 0. We cannot be afraid of that 0 answer. And again, I can substitute this in to check it. I can say 3 times 5 minus 2 times 0. Well, 2 times 0 is 0. So I really have 3 times 5, which is 15. And over here, I'd have 0 plus 15, which is 15, so it works out. All right, over here, again, I'm going to draw my line. And I have some like terms that I can combine only on this left side here. So when I have terms on the same side of the equal bar that can be cleaned up or combined, put together, I do exactly the operation that I see. I see 3 plus 1, which is 4x, and then minus 1 equals 5 plus 2x. I only do opposite operations on opposite sides of the equal bar. And so when I combine like terms like I did here, I'm going to do the exact operation that I see. And now I can start eliminating terms. I'm going to take away 2 x's on each side. I get 2x minus 1 equals 5. I'm going to add 1 to each side. I get 2x equals 6. And I'm going to divide by 2. I get x equals 3. And of course, I can check it. Okay, so your job then is to complete the 3.3. I'm sorry. Your job then is to go work on the 3.3 lesson slides. Those 3.3 lesson slides will be your practice, and it'll be a chance for you to check your understanding on what you learned from this activity. If you have questions, let me know.